Hello, everyone. This is the promised recording of the second class Providence Baptist Church SAT Math, Dr. Reggie Goodwin. And that is my email address, rlgoodwin@aggies.ncat.edu, if you have any questions or concerns that you would like to discuss about the class. I've added a few more slides to this because I really want to talk to the parents, and you'll see why in a moment. Okay, this gentleman with the turban, and the reason why I show this is because our young people are taught to glorify either sports figures or celebrities. This is someone that is marginally part of the culture. Obviously, because of where he's from, he had a little bit of melanin in his skin. And so his name is Muhammad Ibn Musa al-Khwarizmi. And you'll see the significance to this class as I read his bio. Baghdad in the 9th century was a global center of culture and trade, a hub connecting India and China with the Mediterranean and Europe. It was a rich city, a city of learning, and scholars from all over the world would come to study in the House of Wisdom, a renowned library and academy where Muhammad al-Khwarizmi lived as a scholar. Ideas traveled in consort with commerce along the roads of Baghdad, and al-Khwarizmi embodied the wide range of the city's global vision. The Muslim scholar expanded upon the work of Greco-Roman astronomers such as Ptolemy, creating one of the oldest surviving treatises on the Jewish calendar, and employed and popularized the Hindu number system of 1, 2, 3, etc., which, because of al-Khwarizmi's work, we now refer to as the Hindu Arabic numeration. But his most influential work dealt with methods to solve complete equations in the compendious book on calculation by completion and balancing. Al-Khwarizmi demonstrated how to simplify equations by adding or subtracting an identical quantity from both sides. For example, adding 4x to each side of the equation, 6x equals 40 minus 4x, reveals that 10x is equal to 40. This act of completion, al-jabr, gave mathematicians a new tool, what we modernly refer to as algebra. And in the act of completion, 10x equal to 40 is not complete. We have to divide both sides by the 10 in front of the 10x to come to the final solution, x is equal to 4. So we're going through a lot of linear equations. We did not get to systems of equations or quadratic equations. We will cover that in a later lecture. This is also my reminder that we will not have class on November the 4th because of A&T's homecoming. I will be out with the Men's Fellowship at Providence Baptist Church, assembling Thanksgiving meals for needy families in the Greensboro area. I will record, as I'm recording today, the lecture. I will send it to the parents as well as the students. What I need from you is good email addresses. I've gotten some bounce backs from both the students as well as the parents. So please, please make sure that I have an accurate email address so that I can send you the lecture. And then we will resume our lectures after November the 11th for our final lecture, which will be November the 18th. Now, I want to talk to the parents because I did talk to your students. This is kind of how I teach, and I teach this way for a reason. It allows for breaks. So you do 25 minutes of concentrated effort and you get 5-minute breaks. So if you notice, you go from 9 to 9:25, 5-minute break, 9:30 to 9:55, 5-minute break, and then the last 15 minutes. At that point, they can ask me questions, or we just cover topics that I didn't quite get to. And then they transition to their next class, so they kind of have a 10-minute break. This models exactly how we did it before the pandemic. But in that 10 minutes, they're either going to the bathroom, but they're literally physically walking to another class. All they're doing at 10:25 is logging on to their next class. If they've been with me for math, then at 10:25, they're logging on for the verbal. If they've been with the verbal teacher from 9 a.m., then at 10:25, they're logging on with me. And then we do the same thing, lecture break, questions. And as I said, I will record myself addressing your questions, posting it to YouTube for your review, sending you the link. But resources are only valuable if you actually use them. These are the links that I'm going to start sending with, as you notice, the 5-minute breaks are incorporated in the schedule. So the 9 o'clock class will get the first link. The 10:25 class will get the second link. I have it set up to where there's a waiting room. I do that purposely so that I can take attendance, just like in any other class. At the end of the semester or at the end of the year, I think the powers are doing it at the end of the semester, but they do give awards for attendance. So please be sure that, at least for me, that they log in about 5 minutes before the class so I can admit them, take down their attendance, and then we can start again at the appointed time, because the later they come into my class, the less learning they're going to get, because once I start at that time, I'm not going to go back. Fair warning. I wanted to give you a comparison because I actually paid for Huntington, and that's about the price of what you would pay. If you noticed in the highlighted portion, I remember paying roughly about $2,600. That was many years ago for my youngest son, and it raised his SAT very high. Okay. Kaplan is a little cheaper, if you notice, about $6.99 or $21 per hour. What we're asking for at Providence is you have two choices of buying the Princeton Review. The more expensive choice is the big paperback, which is right next to me. The least expensive review, which is less than half the cost, is the Kindle version. So it really depends. I have heard people say that you value what you pay for, but what you are getting is no different than what you're getting at Huntington or what you're getting at Kaplan. You're just not going to pay as much. All we're asking you to do is to pay for the paperback, or as I gave you, the digital version of Kindle. So either way is fine, but it's kind of like saying that the laws of gravity are different at Huntington and Kaplan than at Providence Baptist Church. They're not. I wanted to say that so that you can understand that since there is no longer affirmative action that will be a consideration for your students, they are in a competition. And the people who can pay for the Huntington and the Kaplans are way ahead of people like us. And all we're trying to do is just make sure that our kids can compete on the same level for the same scholarships, for the same positions at the colleges and universities that they want to go to, whether it's an HBCU or PWI. I want them to be successful. And I'm going to stop sharing. And the next part, I'm going to pause this video so you're going to see a lot of pauses. And I'm going to transition to each one of the problems that we covered in the lecture today. So there are going to be some that I'm going to have like a whole bunch of space, because there's going to be two ways that I'm going to work the problems. And then I'm going to add on two bonus problems from the Princeton Review so that you can see what kind of flavor of problem that they should be encountering on the SAT. Not that you're not, I'm just saying I'm sharing it from the Princeton Review. The one that I said was about $30, and then the Kindle one is less than half that. So we'll see you on the other side for problems number 1 and 2. And you'll see that after each set, I'll pause and then we'll go to the next problem. All right, pausing. Problems 1 and problems 2. Problem 1, if A plus 1/2 is equal to 4 plus 2/3, what is the value of A? So you're only given one variable in this. As we progress through, you're going to see that there are going to be multiple variables you'll have to solve for. This one almost looks straightforward. You just have to get A on one side, all the numbers on the other side, add them up. That is a way. The other way that I would like to look at is the least common denominator. In this case, because you have 1/2 and 2/3, your least common denominator is 6. So what we're going to do with that 6, we're going to multiply the 6 on both sides of the equation. 6 times A is 6A. 6 times 1/2 is 3. 6 times 4 is 24. 6 times 2/3, 3 divided by, or 6 divided by 3 is 2. 2 times 2 is 4, 28. So then we're going to get 6A by itself by subtracting 3 from both sides of the equation. Six A is equal to 25. Divide both sides of the equation by 6. The 6's cancel. That leaves A as 4 and 1/6. If 6 minus 3/y is equal to 2, what is the value of y? Well, even though this doesn't look like you have a lot of fractions, you only have one. 6 is understood to be 6/1. 2 is understood to be 2/1. So therefore, your least common denominator is y. So let's multiply y. And then times 2 is just 2y. Six y minus 3 equals 2y. Let's add 3 to both sides of the equation. The 3's cancel here. 6y is equal to 2y plus 3. Let's subtract negative 2y from both sides of the equation. 6y minus 2y is going to be 4y, and that's going to be equal to 3. And then we divide both sides of the equation by 4. The 4's cancel. So y is equal to 3/4. Problem 3. If 2 divided by 7 plus 3 divided by y is equal to 6, what is the value of y? Two methods. First method is that we're going to get the least common denominator. Well, actually, both methods, we're going to get the least common denominator, which you can see is 7y, but we're going to get it two ways. First method is this: 2 over 7 times y over y plus 3 over y times 7 over 7 equals 6. Now, as we say, you have to do the same thing on both sides of the equation. Well, I am doing the same thing on both sides of the equation. I am multiplying 2 over 7 times 1. I am multiplying 3 over y times 1. 6 is, by definition, multiplied times 1. Any number divided by itself is 1. So this comes up in the numerator as 2y, 3 times 7 plus 21. And then 7 times y is 7y. Y times 7 is 7y. So that becomes our denominator, 7y. And that's equal to 6. Now, how will we get rid of this? Well, same thing. We're going to multiply both sides of the equation by the denominator, making that cancel out. So now we have 2y plus 21 equals 42y. Since this is the smaller number, I'm going to take the opposite of 2y and subtract negative 2y from both sides. That leaves me with 21 is equal to 40y. I'm going to divide both sides by 40. 40's canceled. Y is equal to 21 divided by 40. That's method 1. Method 2, I've heard it described by many things. I call it the arrow method. So we're going to take 2 divided by 7 plus 3 divided by y equals 6. Our original equation. This is why I call it the arrow method. I'm gonna indicate that I'm multiplying the two denominators together. And then here I am cross multiplying my y times my y in this denominator times the 2 in this numerator. Then I'm taking this 7 and multiplying the 7 in the first denominator times the 3 in the numerator. We still come up with 2y plus 21 over 7y equals 6. We're still going to do the same thing to get rid of the 7y. We're going to multiply 7y on both sides of the equation. 7y's cancel. 2y plus 21 is equal to 42y. Subtract 2y, both sides. 21 is equal to 40y. Divide both sides by 40. You know you're right when you get the same answer twice. So if c is equal to 1 over x plus 1 over y, and x is greater than y is greater than 0, then which of the following is equal to 1 over c? So that term x is greater than y is greater than 0 Just keep 0 out of the denominator. So there are two ways you can do this. First way we're going to do is algebraically. The second way we're going to do it is by substituting values for x and y, coming up with a number, and then substituting that into each one of the options to see if it gives us that number. So let's start with the algebraic way. We're going to go c is equal to 1 over x plus 1 over y. And remember our arrow method. That's going to be y plus x over xy, which is just equal to x plus y over xy. Now, the temptation is to circle this one, but that's not what it's asking. It's asking for the reciprocal. 1 over c is the reciprocal of this value. So what you do is you take the reciprocal of this value, and that gives you option D, because that's what they're asking you for. Now, the other way is that you can give values to x and y and then solve for it that way. So let's make x equal to 6, y equal to 3. So c is equal to 1 over 6 plus 1 over 3. That's equal to 1 over 6. And another way to write 1 over 3 is 2 over 6. That's going to be equal to 3 over 6. That reduces the lowest terms to 1 over 2, or 1/2. So then the reciprocal of 1 over c is just 2. So what you're looking for is the value of 2. So let's look at 6 plus 3 is 9. No. 6 minus 3 is 3. No. Let's look at this one. C is 6 plus 3 over 6 times 3, which is equal to 9 over 18, which is 9 times 1 over 9 times 2. 9's cancel, 1/2. That's what C is. What they want is D, which looks like what we calculated in the first one for 1 over C. So 6 times 3 over 6 plus 3 equals 18 divided by 9 equals 2. So in both instances, what you've shown is that you can solve for it algebraically, and you can solve for it mathematically. And as long as the two agree with one another, you have the correct answer. Okay, problem number 5. 3 times quantity 1/2 minus y is equal to 3/5 plus 15y. What is the solution to the equation? This is going to sound like a broken record, but you have the opportunity for least common denominator here. The first thing we're going to do is we're going to use PEMDAS. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, add, subtract. That's the order of operations. So the first thing you have to do is get rid of the parentheses. So distribute the 3, you have 3/2 minus 3y is equal to 3 over 5 plus 15y. In this case, you have a 2 in this denominator, you have a 5 in this denominator, so your least common denominator is 10. We're going to take the 10, multiply it to both sides of the equation. Okay. So 5 times 3 is 15. 3 times 10 is minus 30y. 2 times 3 is 6. Plus 10 times 15y is 150y. So we can pick on the little guy. Subtract 6 from both sides. The 6 is canceled here. 15 minus 6 is 9 minus 30y equals 150y. We will now get rid of the negative 30y by adding its opposite to both sides of the equation. That leaves us with 9 equal to 180y. Divide both sides. 180 cancels. Any number divided by itself is 1. We can factor. Doing this for the camera. 9 times 1 over 9 times 20. So you have y equal to 1 over 20, which you can reduce further to a decimal in case that's what the SAT is asking for. Now this one is tricky because your first instinct is to find the value of x, find the value of y, and plug it in for x and y, and try to find the value of 3x plus 2y. Look at what it's asking for. If 1/2 x plus 1/3 y is equal to 4, what is the value of 3x plus 2y? This will show you the power of least common denominator. You now have two fractions. 2 is in this denominator, 3 is in this denominator. So your LCD is 6. Six divided by 2 is 3x. 6 divided by 3 is 2y. What is 3x plus 2y? 6 times 4 is 24. And that's the power of LCD. You just solved that problem in 2 steps. So we're coming into the final stretch of the problems that I did for both classes, 7, 8, and 9. And I'm going to work these 2 ways. I'm going to work them algebraically. And if you notice this call out at the top right-hand corner, first I'm going to work it algebraically without substituting m is equal to 4. And then I'm going to work it by substituting the variable value that I just picked, and then we're going to see if both make sense to each other. So let's do it algebraically. It says solve for x in terms of m. So we have to end up with x on one side, m on the other side. The best way to do this is first subtract x from both sides of this equation. So 2x minus x leaves x minus 3 equals m. To get x by itself, we add the opposite of 3 to both sides of the equation. So then we come up with x is equal to m plus 3. So that's what I mean by solving it algebraically. We solved it without knowing what the value of x is. Now I'm just going to pick a value of x, which I picked this value of m is equal to 4. Starting with our equation, 2x minus 3 equals 4 plus x. I'm going to do the same thing I did before. Subtract the smaller x from both sides of the equation. This leaves me with x minus 3 equals 4. Now I'm going to add 3 to both sides of the equation. The 3's cancel. X is equal to 7. Does that make sense? Let's go back to x equal to m plus 3. We said m is equal to 4. 4 plus 3 is 7. So it does make sense. So basically, by working it two ways, you kind of convince yourself that you are correct. Number 8, solve for x in terms of y. So we have to get x on one side, y on the other side. Here my call out is going to be the second part of this exercise. I've given a value of y equals to 3. So the first thing we can do, we notice that this side is a fraction. So all I'm going to do to get rid of this 2 is multiply 2 on both sides of this equation. The 2's cancel on the left side, and 2 multiplies times y and 2 multiplies times x. So let's write that. 5 plus 6x equals 2y plus 2x. Okay? We are solving for x. So let's get rid of this guy, the smaller x. These two cancel. You have 5 plus 4x equals 2y. Now, to get rid of the 5, we subtract 5, both sides. 4x is equal to 2y minus 5. We're solving for x. Two y minus 5 is equal to x. 2y minus 5 divided by 4, excuse me, is equal to x. Let's see if that makes sense by now giving a value. So we're going to start with this equation after we multiply 2 on both sides to get rid of the 2 here. So we're going to start with 5 plus 6x is equal to, we said our y is 3. So 2 times 3 plus 2x. 5 plus 6x equals 6 plus 2x. Get rid of the lower variable on this side first. because we're solving for x. 5 plus 4x equals 6. Get rid of the 5. 5's canceled here. Now we have 4x is equal to 6 minus 5 is 1. We divide both sides by 4. Now, does this make sense? Let's plug it in. X is equal to 2 times 3 minus 5 over 4 equals 6 minus 5 over 4, which is equal to 1 over 4. They seem to match, which is what we want. So here, instead of solving for x, we're solving for b in terms of a, c, and x. And we're given this weird looking fraction. So again, you have two methods. We're going to solve it similarly to the way we solved problem number 8, which was 5 plus 6x over 2 equals y plus x. We got rid of the 2 by multiplying the denominator on both sides. In this case, your denominator is c minus 3. So we're going to do the same thing. First, we're going to solve it algebraically. Then we're going to use the call outs and see if we get the same answer. Okay. So when I multiply both sides by c minus 3, I just get what was the numerator. Equals x times c minus 3. Now, we are solving for b, so I need to get b by itself. The only way I'm going to get b by itself is taking the variable a and dividing it on both sides of the equation. Of course, the a's cancel here. Now that leaves me with b minus 2 equals x times c minus 3 over a. Now, to get the b by itself, because that's what we're solving for, I'm going to add 2 to both sides of the equation. The 2's cancel here. That leaves me with b is equal to x times c minus 3 over a plus 2. Looks a little weird, but that's the final solution to the answer that we're looking for. So now we're going to start at that second one that we had here. We're going to substitute a is 4 and c is 7. So let's put it here, 4 times b minus 2. Equals x times 7 minus 3. Okay. 4 times b minus 2 is equal to 7 minus 3 is 4. So we can write this as 4x. We get rid of the 4's on both sides. B minus 2 is x. Now we Add the 2 to both sides. B is equal to x plus 2. Now, does that make sense? Well, B is equal to x, C is 7, minus 3, A is 4, plus 2. 7 minus 3 is x, 4 over 4 plus 2. B is therefore equal to x plus 2. Bonus question 1. And my source for this is the SAP Prep Princeton Review Manual. This is the paperback edition, so it's on page 380. I don't know if that is the same as the Kindle edition, but here it is. The length of a certain rectangle is twice the width. If the area of the rectangle is 128, what is the length of the rectangle? So we're given 4 options. Sorry, my neighbor's working on something, if you hear that background noise. So we're given the area is 128, and we know that the area of a rectangle is the length times the width. But we're also given a clue that the length is equal to twice the width. Okay? So then I could take my area formula and I could plug in this, because that's the length, times W. So now we have 128 is equal to 2W squared. We now have an algebraic quantity. We divide both sides by 2. So that is going to give me 12 divided by 2 is 6. 8 divided by 2 is 4. That's going to be W squared. Let's write it this way. W squared is equal to 64. W is equal to plus or minus the square root of 64. We know that's going to be plus or minus 8. So what did we say? We're looking for the length of the rectangle. The width is, we're going to take the positive of this, 8. So the length is 2W. 2 times 8 is 16. Option C. Straight out of the manual. Last bonus, bonus 2, same source in the SAP Prep Manual on page 380. If square root of 2 over 2 is equal to 2 times the square root of 2, what is the value of x? And this should be so let's start that over again. If you will notice, I changed the variable in the equation because it was typed incorrectly. That was sad, but I would like to say, in defense of all things STEM, one of the things that distinguishes people in STEM from people that feel intimidated by it is that we accept mistakes as part of the learning process. So once again, SAT Prep Princeton Review 2023, page 380. Bonus number 2. The last one is the charm. If the square root of x over 2 is equal to 2 over 2, what is the value of x? As you will notice, that makes a heck of a lot more sense. So we're given 4 options. We need to solve for x. What we're going to do is what we've been doing. We're going to take the 2 in the denominator, multiply it on both sides. So root x over 2 So the question is, what happens here to the root 2? Nothing. Absolutely nothing. What's happening is that you're treating that root 2 as if it is a variable itself. Of course, on this side, the 2's cancel. Now you have the square root of x equal to 4 times the square root of 2. And now I'm going to square both sides. That, of course, is going to take away this square root symbol here. So you just have x. And then I'm going to distribute the 2 this way. 4 squared times square root of 2 squared. This is going to be equal to 16 times 2, 32. Option D. I encourage you to buy the SAT Prep manual, either the print edition as I have it, or you can save a little money and go for the digital one, which is less than half. The only way that we're going to get through this, guys, without affirmative action, as Dr. W.E.B. Du Bois said when he graduated from Harvard, what he thought of it, he said, I assure you, the honor is Harvard's. So it is the honor of any university to get your Black brilliance. See you next week.